So having placed the capillary tube into the test tube with the liquid, what I'm going to do now is I'm going to immerse this test tube into, and the thermometer into the oil. Okay, so I'm going to immerse it into the oil, as you can see here. See, I'm going to immerse it into the oil. Immerse it into the oil. Okay, so now it's immersed in the oil. So you can see that it's immersed in the oil now. And so what I'm going to do is, I'm now going to begin to heat the elbow. I'm going to begin to heat the elbow of the Teal Dennis tube. Like I told you, it's very important that you don't heat the elbow too quickly. You don't want to heat the oil too quickly, because if you heat it too quickly, what's going to happen is that the boiling point of the liquid will be exceeded, and if you keep heating over the boiling point, what's going to happen is that all the liquid will boil away. So you don't want all the liquid to boil away, because if all the liquid boils away, what's going to happen is that you won't have any more liquid to determine the boiling point. And so you want to just watch. See, just watch, make sure that the temperature is not rising yet. Okay, but immediately the temperature starts rising, it's at that point that you want to take away the heat source. I'm still heating, as you can see. I'm still heating. Okay, I'm still heating. I'm still heating. And now the temperature starts to rise. Notice that the temperature is rising now. The temperature is rising. Now it's rising. It's rising. Temperature is rising. It's rising. Okay. Now, like I told you, what's going to happen is eventually the boiling point is going to be reached. And once the boiling point is reached, you're going to see that bubbles will start to come out from the open end of the tube. Okay, you can't really see that yet because the boiling point has not been reached. Okay, but what you can see that is that the temperature of the thermometer is still rising. Remember, I told you that it takes time for the heat to travel throughout the entire setup. It takes time for the heat to travel throughout the entire setup. So you have to heat slowly. Okay, once you see that bubbles start coming out, you want to take away the heat source. Okay, so when you see that bubbles start coming out, you're going to take away the heat source. So let's keep watching and seeing if bubbles are coming out. Right now, the bubbles will start coming out at a uniform speed, as a constant speed. Is at that point that you need to take away the heat source. But at this time, we don't really have that happening. Okay, we don't have that happening. The bubbles are coming out, but really slowly. But when the bubbles start coming out constantly, right, at a uniform speed, you want to take away the heat source. Okay, and you're going to see that shortly. See, you can see that the bubbles is coming out. The bubbles are coming out, but it's not really quick, fast enough. All right, now once you see that the bubbles start coming out at a very rapid speed, you want to take away the heat source. You can see the bubbles are coming out now. Bubble that's coming out. So we have taken away the heat source. Because if you don't take away the heat source, what's going to happen is that this entire liquid will boil away. And if the entire liquid boils away, then what that means is that you won't have any liquid to determine the boiling point. And remember, the boiling point is the temperature at which the vapor pressure of a liquid equals the atmospheric pressure. The boiling point is the temperature at which the vapor pressure of a liquid equals the atmospheric pressure. But now, the reason why the bubbles are coming out is because the vapor pressure of the liquid is greater than the atmospheric pressure. Now, because we have stopped heating, the vapor pressure of the liquid is now going to begin to decrease because As the temperature decreases, the vapor pressure of the liquid will decrease. It will keep decreasing until we get to the boiling point. In other words, when the vapor pressure of that liquid becomes equal to the atmospheric pressure, the bubbling is going to stop. And once the bubbles stop coming out, you're going to see that the liquid will start to rise in the capillary tube. Okay. You can see the bubbles are coming up, but really slowly. So what is this telling us is that the vapor pressure of the liquid is almost equal to the atmospheric pressure. That is why the bubbling is slowing down. Once the vapor pressure of the liquid equals the atmospheric pressure, the bubbling is going to stop. You're going to see that the very last bubble will come out, and then the liquid will start to rise in the capillary tube. So that's what you're looking for. So you can see that the liquid is now rising in the capillary tube, and we are at 77 degrees. So we're at 77 degrees, so that's going to be the boiling point. See, we are at 77 degrees now, and that's the boiling point. That's the boiling point. So we have determined the boiling point of the liquid to be 77 degrees. So anyways, like I said, I'm just going to round up real quick. You record the temperature of the thermometer immediately when you see the last bubble come out and the liquid starts to rise in the capillary tube. That's when you record the boiling point. At that point, when the last bubble comes out and the liquid starts to rise in the capillary tube, what that is telling you is that the vapor pressure is now equal to the atmospheric pressure, and that is the boiling point. What I found out to be today was 77 degrees. All right, so I hope this helps. I'll see you guys shortly. Bye for now.